Hey everybody, and welcome back to another video on my channel. So I figured I would do a very basic mini-series in regards to doing interactables within the GASP environment. So as you can see here in my video, I have a beautifully crafted chest and a door blueprint where when I click my left mouse button, you'll see that a line trace happens that interacts with the door and causes it to swing open. And then if I look at the door and click at it again, it closes. And then if I look at my chest, you can see that the top opens and that if I click on it again, that the top closes. So that is what we're going to be doing in this little mini series to try to set up a very basic interactable. So, and the reason I'm calling it a mini series is because I want to make it digestible just because of the stuff that we'll be going over, or I will be doing my best to explain. So let's go ahead and get right into the video by starting with a very simple line trace function. So let's go ahead and hop into that. Alright guys, so as you can see, I have a new project open and whatnot within the game animation sample project. However, you're more than welcome to do a brand new project within the third person template. The way I'll be demonstrating this will work in both environments. So if you don't want to touch anything in the game animation sample project, or maybe you're building your own thing from scratch, you're more than welcome to pull up your 3D person or your third person template and work at it from there, starting with the basic stuff, right? So in this video, what we're going to be doing is a very simple line trace to try to make it like a standalone thing, so that way if anybody else wants to just do line traces, then you could just do line traces. And then the next part will be opening up, creating doors, chests, and whatnot, and making blueprint interfaces, stuff like that. So within our game animation sample project, or your third person template, what I want you to do is go ahead and open up the blueprints folder and then go into the CBP sandbox character and open that up. So once we are in our sandbox character, what we are going to do is we are going to create a function to contain our line trace in, and I will be explaining how the line trace works. So we're going to go over here to the side where we have functions, and we're going to hit the plus. And what I'm going to do is call this function, I'm going to call it interaction. Let's do interaction line trace, actually. Just that way we know what this is. But you can just pretty much call it interaction if you wanted to. It's going to be that simple. So the first thing we're going to get is we're going to right click into the area and return a line trace by channel, specifically this one. So as you can see with the description, it does a collision trace along the given line and returns the first blocking hit encountered. This trace finds the object that responds to the given trace channel and also like gives a return back of a value of whatever. So we're going to grab that, and as you can see, we have our line trace. So within our line trace, as you can see, like all these different things that are in the line trace, here we're going to do the start of our line trace, where basically what we're trying to do is get the starting point location of where we want to start it from. Because if we set it to the default values that you see here at 000, basically what you're saying is start at the world origin of your line trace, right? So I'll give you an example. So let me do this, and I'm going to do a return node, just that way we can return some stuff, right? So I'm going to compile and save. I'm going to go into the event graph, and let's just say we get our left mouse button for debugging, because that for line tracing, I like to do the left mouse button as it's just convenient to be able to spam it for when I'm trying to do line trace testing. So say we do this, we hook it up to our pressed, and I go to the interaction line, and let's just do this. I'm going to do a get actor location so I can get my actor's location, and we're just going to do it at the end location, right? So if I compile and save and go hit play, so like I said, the 000 is the world origin, or the starting point to this world. So wherever that is, we're about to find out. So wherever it starts from, it is then going to trace and end at our character. So if I hit the left mouse button now, or actually hang on, I didn't set the visibility. So we have visibility, and our draw debug type, we want a duration, and I'm going to keep it 5 seconds. So make sure that when you are doing debug testing for line tracing, set your draw debug type, and typically I set it for duration, because if you do it for persistent, it pretty much remains on the play area and I believe doesn't go away. For 1 frame, meaning like, so 1 event tick frame, it just happens, it just spawns. Which, you know, for our purpose, since we are trying to debug, we want a duration. But typically, when you do actual interactions and stuff like that, you don't want debuggings hanging around. So pretty much you would kind of do it for like 1 frame when you're actually doing legit prototyping testing. So we're going to keep it on duration, and I'm going to keep the draw time of drawing this debug for 5 seconds. So if we compile and save and now hit play, you can see where our line juts out at. So if I go around, you can see on the U that is our start point and it ends at our character. So that U is our world origin, our 000 basically for that start location, and it ends at our character. So now, if, say for example, we switch it, and let's say we want to start at our character and end at the world origin, if I compile and save and hit play, you can see now that it does the same thing and it collides at the world origin, which is that right there. So now, say for example, I wanted to give a new location, right? Say I wanted a different end zone, whatever, where I wanted to end at. Let's give it an X on 100 and maybe, you know, 50 on the Y, probably, right? Or on the Z, my bad. So because we've changed the vector location of our line trace ending, if I hit compile and hit play, you can see that we are still getting to that point, but we are now like offset ever so slightly by 100. It's no longer at the middle of this plus. It is now ending just 100 ahead of it and 50 units above the border of it. So as you can see, we now have a different end location, right? So to actually get an end location like how we have here for our line trace, so when we do traversal actions here in the game animation sample project, we do some mathematical functions through our pure function to get a line trace that is ahead of us. And then in the traversal action, it does a lot of other checks and does capsule traces instead to get a traversable level block location, and then cast our like capsule tracing to a ledge in order to climb over. So we're kind of doing similar checks with our interaction line trace here. So in our interaction line trace, say we want something a bit different per se, right? Like, let's say that we want to go ahead of our actor, right? So we could see how when we got our actor location for the start, the start point is our actor's location, but say we wanted to end, you know, in front of our actor to a certain degree. So what you'll end up doing is if I get my actor location again and I go off of it or drag off of it and say hit a plus, because now what we want to try to do is add like a distance in front of us to a certain degree. So we're going to drag off the output of this plus node into our end. And let's say I do, I don't know, like 1,000, 1,000, 1,000, just to make it very simple. And I hit compile and save, and then I play. As you can see now, how our line tracing is basically going to the right diagonal upward direction from our actor location. So there's not a specific point anymore. It's basically ending to a specific point, like wherever our character is moving. So that is what is called our offset, basically, is that we're offsetting from our actor location a little bit away from our actor to get our end result. So now, to get a little bit more in front of our actor, what we need to do now is do a multiplicative offset. And what I mean by that is when you do the the multiplication to get our offset. Basically, it will do the rotation for you and also set it at proper anglings and other stuff to get it in front of you. And it's kind of hard for me to explain exactly what it does, because it's one of those things that with me testing it and trying it out and seeing how other people do it, see how the Game Animation Sample Project does it, and especially the things that I've looked up and done, it is kind of hard to explain like how it works, but I'm going to show you so that way you get the idea of what's going on. So what I'm going to do now is I'm going to grab the actor's forward vector. Because again, what we've done here is our start point is at the actor's location, and then our end point is our actor's location again, with an offset to go at a certain direction from our character, and we get that in location. So as you saw when we moved around, it was constantly going to the upper right of our character because I just set it to whatever, 1,000. So here what we're going to do is we're going to make a brand new offset, or at least the second input for our offset, in order to get the line to appear in front of us. So what we want to do is grab the actor's forward vector, because that offset, we want to make sure that it appears directly in front of the actor when we click our left mouse button. So off of this, what we're going to do is do a multiply operator. And the reason for this is because what we're trying to do now is get our actor's forward vector, but then multiply it to give us a certain distance ahead of us. So not only is it going to rotate it for us appropriately in front of the actor, we are also going to do a distance for the line trace. So I'm going to convert this into a float, because what we were trying to do is we want to multiply all the vector values, so the X, Y, and Z of this, by a float. So that's why when you see multiplicatives or additions of a float to a vector, what it's essentially doing is adding that float or multiplying that float to all angles of that vector. So in this case, what I'm going to do is I'm going to give I'm going to call it quote unquote our interaction distance. So I'm going to give an interaction distance of 200. So what it's doing is it's going to take our forward vector. So this is going to be at 0, 0, 0 or whatever, or as you can see right there, the length of 1, and we're going to multiply it by 200. So we're now going to have an output of 200. However, when we're going to connect our output into the second input of the addition node, where now the output of, 111 times 200, we're going to get 200, 200, 200. And then we're going to add that into this second input pin to give our offset to our actor location. So now when we do that, if we compile and save and I hit play, you can see now that the line trace is in front of the character no matter where we turn and do, because wherever we turn, that'll be our actor's forward vector regardless. So if I turn around, you can see that always in front of where we're facing, there will be a line trace, right? So already there we have our distance set up. We've set the line tracing to end in front of our actor and no longer to like the upper right or wherever location you're going. So just to recap it, we give an offset to our actor location. So if I would have just done actor location to actor location, it would have just been like a very small bump within the character. It wouldn't have done anything. So then we've added an offset to not only rotate the line trace around, but also to appear in front of the character. And then what we did was we expanded that line forward by a distance of 200. So instead of a x1, y1, z1, we have an x200, y200, z200, and we threw that into the offset. So that's how we get it in front of us. So now what we're going to do is, a lot of people may be wanting like their, say for example, their character to wherever they're looking at, they want to be able to interact with, and maybe they want the line trace to not be at a certain body part of the character. Maybe they want to start it from the face or start it from the chest, anything like that, right? So in order to do that, I'm going to move here and we need to add another offset, right? So if we add a pin, and let me move this over real quick. So if we add a new pin, we can now change other parameters or add another offset value to our endpoint, because we already get in front of us, we already get, you know, to a certain body part of our character, and we end the line trace in front of us. But say I want my line trace to appear off my chest or my face, right? So what I'm going to do is on the Z, I'm going to bump it up 70 units, right? So if I compile and save it and hit play, you can now see that it is going up the Z just ever so slightly, right? So it technically is now appearing at our face. However, we are now getting, you know, from our character's, you know, pelvic bone or, you know, groin area, that it's now going up. So now we have to then move the starting point up, because we've already modified the endpoint to be upward. So now what we have to do is, off our starting point, to be able to start it at our face, we need to drag off and do an addition node, and then connect our output into the start, because now we have to offset our start location. So because I want it to be 70 upwards, so it's from the face to, you know, wherever we're looking at, we now need to do this Z at a 70. So if I compile and save and hit plus, you can now see that from our face or from our eyes, wherever we're forward looking at, we now get the line trace. So that's cool, right? Awesome. However, again, people are going to want to be able to look wherever they're at and be able to then send a line trace to whatever location they want in order to be able to do something. So in order to do that, we want the end location of where we're looking to be where we interact with. So that's where we then have to modify where our endpoint is at. So instead of, normally people would add a camera, like they would probably take their camera mesh and put it in here, but what I found to be decent or working a little bit better for my needs is inside I would do a get player camera manager, because as you can see, it returns the camera manager for the player controller at the specified player index. This will not include remote clients with no player controller. So what that means is this player index, like if you're doing, say, multiplayer or whatever, or there's just a lot of players or player controllers, etc., like in the game, then there will be an index number that you can provide, like 0, 1, 2, 3, 4, you know, all the way up to I want to say, like, for integers 2 million, right? So that's how you can then separate, like, whose camera is what, you know, for wherever they're looking. So in this case, what we would want to do is we want to do the forward vector, because wherever we're looking at, we want wherever our camera is looking, and whatever forward vector of the camera times our interaction distance of 200 to then be offset and end wherever the camera is looking. So if I compile and save now and I hit plus, you can now see that wherever we are looking at, our camera now, you know, collides with wherever we're looking at or whatever our end zone is. So that is pretty cool. I like that much better. However, like I've said, people will do like camera managers into here, but I've found that this works for my needs because I would rather interact from the face or maybe from the chest. So, you know, if you wanted to do something like the chest, maybe you would do like 45 here, and if I did start compile and play, you could see now that from the chest or at a certain point of the chest that we are doing these collisions. So this is pretty much kind of the basic setup of how you would do a very decent or good line trace, right? So one of the things that I like to do preferably is I'm going to make this a little bit more advanced for the needs of being able to nicely, you know, make this nicer or look nicer, right? So what I'm going to do is off the line trace, I'm going to draw. So because we don't need this anywhere else, it's because we're targeting ourselves within this function. But say, for example, you make an actor component, right? Well, if you do an actor component, what you would want to do is connect these targets into here where to make its own input. And what I like to do to be able to differentiate, what I need to connect into it, normally I would do something like this where it's target parentheses self. So then, because the other actor location has target self, I can plug it into the same thing. And then lastly, what I like to do is I want to be able to modify the draw debug type and the draw time depending on my needs. You can also do trace color if you want. So what I like to do is off the draw debug type is connect it to our interaction line trace to create an input for it. And I'm going to make these connection points to pretty it up so that way we can get to our return or our input nicely. And then I like to then connect the draw time into the input to... Hey guys, apologies about that. It looks like my computer just crashed for no reason. I got to figure out what happened there, but I had to put in like a little interruption or a technical difficulty there just because that is literally what happened. So, however, when it crashed on me, it looks like it still left this up for me. So I'm going to continue where I left off just because I don't want to redo the whole video. I want to just kind of add on to it and go as far as this mini-series. So I do apologize for the sudden technical difficulty interruption as far as that goes. But to continue off of what I was trying to say, so as you can see with our input for our function that I add the target self and the draw debug type here. So then for the draw time, I like to also attach that here, or oops, if I like to attach that here, and then pretty that up. And you're gonna see why I have all of these inputs and to kind of go over, stuff like if you did an actor component or anything like that for line tracing for maybe like your AIs and stuff like that. So another thing that I like to throw in here, and let me move that over, is the trace color in case I want to modify that, and then the trace hit color. So let me go ahead and move these down real quick. And let's see. Yep. And so once we have that, now you can see that this is pretty much the basic setup that I typically like to do. Typically, I don't care about the trace complex or the ignore self. I just leave those as default. But there are times when maybe I want to, do different trace colors and other stuff, and I'll be able to modify draw times and debug selves or debug types. But like the target self, like I said, if you ever were to have, say, like AI characters built off of child blueprints, stuff like that, then what you would do is target the self. You would throw the actor component into that, that character or that character blueprint, and then call self on that character, so that way it knows that it's referring to itself. So with that off the return node, what I want to do is get our out hit and our return hit, so that way when we call it, we have everything that truly that I need, right? So if I do a compile and save, and I go back into the event graph, we now have our stuff here that's set to default and that we have to now refix. So what I'm going to do is quickly put these to where I had it. So, for the trace color, what I want here is I want it green. Oop, yes, hit OK. And then the hit color, I want, red, stuff like that. So now if we do a compile and save and then hit play, so when we do it, you can see, oh yeah, I didn't set the stuff yet. Hang on. So I forgot, my apologies guys. There is one other thing that we got to do. So what I then like to do, because we do have to now set up our interaction distance and stuff like that, what I like to do is do a few other things for our interaction line tracing because of how we are now connecting inputs into our input function, or the input part of our function. So what I'm going to do is I'm going to add two variables into our input, right? So what I want the first one to be is a Z offset. So just like this. And I want to change the Boolean to a vector type, because what I'm going to show you is how to do read-only variables without you having to put local variables or variables in here. So off of our input, what you can then do is right-click into the space and do a get Z offset. Oop, if I could spell it right, Z offset. And there you go. We are now retrieving our read-only value from the input part of our function. So if I do that and grab the Z offset, what I'm going to do is I'm going to throw it here and I'm going to throw it here because I typically like to have the Z offset at the same place. So I'm going to put it to 70 for both of them. So I'm going to connect it into the output or the input pins of these addition nodes here. And then we'll change it to 70 when we get back out. And then the last input, what I like to do is I like to call it interaction distance, just like that. And I'm going to change it to a float because what we're going to do now is convert this into that number. So I'm going to do get interaction distance, just like that. So we're retrieving our read-only value from our input box of the function. And I'm going to then plug it into here. So now, as you see, we pretty much have like nice, read-only stuff, or, getting all of our variables from here. So if I do a compile and save and go back into our event graph, so we have the target as our self, which we need to then call self here, because self in this instance of the function, I believe is referring to just I think it's the sandbox character as well, or wherever you're getting it from, because technically if you were to make an actor component, this target self would be connected to like the actor component if you made it and added it to the character, as to where what we truly want is this target self, where we then call self here. So now off the Z offset, I'm going to then, make it 70 like I was originally talking about, and our interaction distance of 200. So now when I compile and save and go back into play, you can now see that we have our green, output, and we are hitting stuff, whatnot. So the reason you're still seeing green on the impact is because past it is now the red part, So if I were to, let's say, go here to this 1 meter block and do that, you will see now red comes out of it when we do actually hit or impact it, where a little bit afterward we get that red. So that is pretty much what we are going to be, that is pretty much what this video is about, where we now set up the interaction line trace for what we want, or what we want our character to have when we start doing the interactables and the interaction stuff in the future videos. So hopefully this has been educational for you guys. And again, I do apologize for the sudden interruption for my video when my computer crashed. Again, I can't explain it, but luckily I was able to save some of the video, and I was able to just continue off of it by throwing in a little, technical difficulties, little meme that I created. So other than that, guys, if you did find the video educational in regards to line tracings and how that works, and thinking about how the offsets work and stuff like that, and how we created a function with all these input types that we can configure ourselves, or at least the primary stuff that we want to configure ourselves. Hopefully you enjoyed it, and if you did, please go ahead and check out my other videos, and also hopefully my future videos to come. So other than that, guys, y'all have a great rest of your day and take care.